Sure your folders look like this. Hopefully the colors are the same, but they might not be the same. Just follow the the titles of the pictures. Okay, so today we're doing 1.5 part 2. So we're starting with linear pairs, and then we'll do vertical angles. So linear pairs are two angles that are adjacent, so they share a side, and they are supplementary, so they add to 180. So if they share a side and they make 180, that means that the other sides that they don't share make a line. So like angle 1 is made up of this angle, or this side right here, and this side right here. Now it shares a side with angle 2, and angle 2's other side is right here. See how the side they don't share make this line? That makes them a linear pair. And I like to draw this little half circle because a half circle is 180 degrees. So that's a great way to be able to tell that they make that they're supplementary 180 degrees. If you cannot draw the little half circle, then they are not a linear pair. So 1 and 2 are a linear pair. 3 and 2 are a linear pair. 4 and 3 are a linear pair, and 4 and 1 are a linear pair. 5 and 6 are a linear pair, and 7 and 8. Now what I see a lot of people do on this is they try to tell me that 3 and 7 are both on this line right here, so they're a linear pair. It's not true at all because they're not adjacent. They have to share a side, and these two angles do not share a side. They have to be right next to each other. So our geometry statement is that linear pairs are supplementary. And I believe on your notes it says the measure of angle 1 plus the measure of angle 2 equals 180. This is like what you would write in a proof. So like on something like this. Angle A, B, E, and angle something are a linear pair. Now when I do this in class, everyone yells out the wrong answer. So ABE and one other angle have to share a side and make a line. So there is no other angle that shares this side. There are other angles that share this side, so it has to share this side, and then it has to make a line with this side. So it has to be going this way. So it has to be this angle right here. There's only one angle it could be. That's EBC. You could also call it CBE. That's fine. And then angle ABF is a linear pair with angle FBC. And angle ABH is a linear pair with angle, I'm just doing an and sign, I'm not adding them together, HBC. You don't have that on your notes. That's just one that I've added to kind of show you what I'm talking about. Okay, so we have a linear pair. So the measure of angle ABD plus the measure of angle DBC equals 180. And that's because linear pairs are supplementary. The second step is always substitution. So we have 7x plus 2x equals 180. You combine those, you get 9x equals 180. You could put combined like terms or arithmetic either way. I like to put combined like terms if I'm adding x's together. Then you divide both sides by 9 and you get x equals 20, and that's division. So that's a pretty easy proof. Okay, find the measure of angle ABD and angle DBC. So I'm going to do this first one, and then I'm going to have you pause it and try this one. So these are a linear pair, Added together, they should equal 180. I'm going to go ahead and combine them in my head. So 4x plus 11x is 15x. Positive 6 and a negative 6 actually cancel out. They add to 0, so I'm not even going to write them down. And that equals 180. So then if I divide, I get x equals 12. So then I need to do 4 times 12 plus 6. And on this one, it's 11 times 12 minus 6. If you solve those, you should get 54 and 126. So pause the video and try this one, then I'll work it out. So I'm going to combine my like terms. 10x and 9x make 19x. 1 and negative 11 make negative 10. So I get 10 for x. 10 times 10 is 100 plus 1 is 101. 9 times 10 is 90 minus 11 is 79. Okay, so anytime we have two lines crossing, we have 6 things happening. You don't have this slide either. I'm just trying to show you. So we have linear pairs. One pair right there. One pair right here. One pair right here. And one pair right here. So each one of these angles has, two different angles that are linear pairs. So let's say that this is 80. Well, because this is a linear pair, this has to be 100. And because this one's a linear pair, it also has to be 100. And this one is a linear pair to both of these, so it has to be 80. So notice, when we have two lines crossing, there's only 2 different angle measures. So we've got 4 linear pairs, and those are the ones that add to 180. But then we've got like this one and this one. Those are the same, but they're not linear pairs. And those are the same and they're not linear pairs. We call those vertical angles. Vertical angles are always congruent. So that's what this next slide is. It's the 2 angles across from each other, like this. And like honestly, these are also vertical angles, but that doesn't make it look very good. So 4 and 2 are vertical angles, and 1 and 3 are vertical angles. And I think you also have this on the same slide that says vertical angles are congruent. So these are congruent, their measures equal, and these are congruent to each other. So right here, the measure of angle RSU plus the measure of angle TS, oh wait, I'm sorry, I messed up. You don't add them. They're vertical angles. Sorry, I'm used to doing linear pairs. So these are congruent. So that equals the measure of angle TSV. And that's because vertical angles, that's the angle symbol, are congruent. So congruent sign is an equal sign with a little squiggly above it. The second step is always substitution. So we get 9x plus 9 equals 12x. Then I would subtract my 9x and get 9 equals 3x. That's subtraction. Then I would divide both sides by 3. That's division. Then you flip it around, and that's symmetric property. Okay, so I'm going to try this first one, then I want you to try the second one. So these two are vertical angles. I like vertical angles because I like setting things equal. I don't know why. However, if I set this equal to this, I won't be able to solve it because I have an x and a y. So because I need to put these together first, I have to think about what kind of angles these are. And those are linear pairs. So remember, a linear pair adds together to get 180. So I'm going to start with a linear pair. So I get 8x minus 20 equals 180. Add the 20, you get 8x equals 200. Divide by 8, you get x equals 25. Now if I plug 25 in right here, 25 times 6 is 150 minus 11, that's 139. 25 times 2 is 50 minus 9 is 41. So those are my two angle measures. And remember, when two lines cross, you only get two different angle measures. So if I know these two, I easily can get those two. So if this is 41, this one's 41, and this one's 139 because of vertical angles. Now, we're not going to do any after this, so yours might be on two separate slides, or if you have another slide, you can just solve this problem on that one because you won't need any more slides. It depends on what kind of notes you have. But because I know that 20y plus 19 has to be 139, I can say 20y plus 19 equals 139. I got the 139, remember, because I plugged in 25 here, and this angle is 139. So then these are vertical angles. Then I'd subtract the 19 and get 20y equals 120. Divide both sides by 20 and you get y equals 6. So I'd like you to do the next one on your own. And see what you get. I'm going to, real fast, just make it a little easier. Clear off some space. Okay. So remember, these are the same, but those you can't set equal because one has an x and one has a y. So these two are a linear pair. So 10x plus 7 plus 9x plus 2 have to equal 180. So 19x plus 9 equals 180. Subtract the 9 from both sides, you get 19x equals 179. So x equals, 171. And so x equals 9. If I plug 9 in, 10 times 9 plus 7 gets me 97. 9 times 9 is 81, plus 2 is 83. So this angle is 83, this angle is 97 because of vertical angles. Then I can say 18y plus 25 equals 97. Subtract the 25 and you get 18y equals 72. Then you divide and you get y equals 4. Yay!